It's October 31, 2017. And here is a Cushman Model CE1 communications monitor that I picked up at a Hamfest, non-working. Had a lot wrong with it. Had to rebuild the power supply. A lot of components out of tolerance. A lot of resistors had changed value. Quite a few tantalum capacitors, 10 microfarad 35 volt tantalums, the small green ones, that were either leaky or shorted. Anyway, this thing will generate between 10 kilohertz and 1 gigahertz, and it will monitor 50 kilohertz through 1 gigahertz with the proper plugins. I got two plugins with it. This plug-in right now, the model 314, is a high sensitivity mixer that goes from 20 megahertz to 1000 megahertz. This is basically a dual conversion super heterodyne unit with the plug-in is the input, RF input on it. The incoming signal coming into the mixer there, in the upper right compartment, that's mixed with a local oscillator, and it's mixed down to 10 megahertz, which is the first IF, and then it's mixed down again to 100 kilohertz. In that point, it's supplied to a discriminator and an oscilloscope on the left, the upper left compartment, that measures the modulation, monitors the modulation output of it. When it's in the generator mode, the synthesizer that's used as a local oscillator is shifted 10 megahertz down, and then they use that as the frequency output. That comes out on these jacks down here. The frequency is set by these controls along the right here, where you can dial in the frequency up to approximately gigahertz. 999.9999 is the top signal. You can frequency modulate it with an internal tone generator here, and you can adjust the modulation here, and it's all monitored on the scope. It's got a frequency meter here that shows the frequency error. The frequency meter will measure full scale 1.55 or 15 kilohertz. And here's the scope on the left hand side here. You can also monitor the frequency deviation with the control here, which will measure 1.55 and 15 kilohertz, which is measured on the scope here, which I'll demonstrate in a minute. There's numerous plugins available for this. AM plug-in. It's set up here for frequency. This one, like I say, goes from 20 megahertz to 1000 megahertz. And let's see. The next step will be running some signals into it and making a couple measurements here. So stand by. Okay, I'm going to apply an input signal on the frequency counter here. This is just calibrated to a rubidium frequency standard here, so it's 2 cycles off, 147 megacycles. And we're going to apply that to the input. Okay, I'm applying a 147 megacycle input to the input of the plug-in. Okay, I'm monitoring, and now I'm going to change here the frequency. There's 1 kilohertz. Notice the frequency meter has shown 1 kilohertz, 2 kilohertz, 2 kilohertz, 3 kilohertz, and we're down 3 kilohertz, 4, 5 kilohertz. Okay, we can also go here. Okay, we're on frequency, and we'll go 1 kilohertz. This is measuring up to 5 kilohertz deviation. Deviation here is 0, 1, 2, 3, 4, and 5. So there's 1, 2, 3, 4, 5. Okay, now I'm going to frequency modulate this signal here. We'll start with 1 kilohertz. One kilohertz modulation. I'm sorry, deviation. There's 2 kilohertz. Three, 4, 5 kilohertz deviation. So the scope here is showing the deviation from 0 to 5 kilohertz. You can change the sweep speed here, the horizontal microseconds per division. Now I'm going to transmit a signal with a handy talkie here on 147 megacycles and pick it up on the antenna here. Test 1, 2, 3. Test 1, 2, 3. Testing. Hello, hello, hello. Test. So on the oscilloscope here, it is showing the deviation from the incoming signal. And of course the frequency is set to 147. This unit was really a pleasure to work on. Underneath, all of the plug-in boards are all gold-plated, are in edge connectors. This shows the oscilloscope plug-in, which is secured here. It has a 5 megahertz ovenized quartz oscillator here. Power supply is in the back. That's been all rebuilt. It's a pretty solid piece of equipment. The castings in the center here have all of the higher microwave frequencies inside. It's a cast unit down the center of the device here. Here's the unit generating a 147 megacycle signal, and I will FM modulate it at 1 kilohertz. With a modulation adjustment here, I can raise it on the scope. There's 1, 2, 3, 4, 5 kilohertz deviation. And here on the spectrum analyzer you can see the signal. Center frequency 147 megahertz, a span of 3.5 megahertz. Here's some of the parts I had to replace to get this thing running. These tantalum capacitors were a real pain. 10 microfarads at 35 volts. Every single one of these was either leaking or shorted. The main power supply filter caps were all leaky, old ones. I had one transistor 3055 in the 20 volt rail that was bad. Of course the fuse was bad. Numerous resistors that were out of tolerance. One transistor, at least one transistor, I think there was 2. A couple diodes were bad. A couple diodes across the meter were shorted. They had to be replaced. So There's a lot into getting this thing running again. It took a while. Oh, this one's leaking. Pretty obvious. Anyway, it was worth fixing. It's a nice unit. It nowhere compares to this one, the HP 8920. This thing does just about everything. But the older technology is still fun to play with. This unit will automatically test receivers, or it's set up, push a button, transmitter. It'll measure all the parameters you want. Everything is calibrated against this rubidium frequency standard. It outputs a 10 megahertz signal. Very accurate. This is an older HP quartz oscillator that's got a ovenized oscillator in it, very accurate for the time. Another unit here, the IFR 1500. This is another nice unit. Not quite as good in my opinion than the HP, but it does a lot. Both the HP and this one have a tracking generator in it, which are really nice for adjusting filters and things like that. Here's another old service monitor. This one goes way back. This is a Singer FM10C. This one goes up to, I believe, a little above 500 megacycles. Covers a VHF, UHF band. This is my first service monitor. A lot of use. I have another one just like this. This one needs a little work done. The scope's got a problem with it. I do have all the manuals for it though, so that shouldn't be a problem. Well, that's about it for today. This unit, I think it was worth the effort to get it running again. I'm not going to use it that often, but it's a nice unit. And in its day, it was a workhorse for the communication technicians that worked on the older equipment. So that's it for today. October 31st, 2017. Signing off.